Hello, in this video we're going to look at some exponential functions that are involved in more complicated chain rules. So our first example, we have y equals 65 over 18 plus 3e to the negative 4x. So this one, we could treat this as a quotient rule, but given the fact that our numerator is a constant, what we may want to do is rewrite this where we have 65 times that denominator raised to the negative first power. That will avoid the quotient rule a little bit, but it'll work out and make that the calculus and the algebra a little bit easier. All right, so anytime we have, this is a chain rule problem, we have something that's not just an x raised to a power. So the derivative of 65 times something to the negative 1 is going to be negative 65 times that something to the negative 2. Since that is not just an x there, we do need to multiply by the derivative of the inside. The derivative of 18 is 0. The derivative of 3e to the negative 4x is going to be 3e to the negative 4x. And then now we have a chain rule again because our exponent here is more than just an x, so we need to multiply by the derivative of that inside. All right, so when we simplify this, we've got negative 65 times 3 times negative 4. Negative times a negative is going to give us a positive. 65 times 3 times 4 is 780. We still have that e to the negative 4x, and 18 plus 3e to the negative 4x quantity raised to the negative 2. Now, negatives in the exponents, it technically is more simple to go ahead and put those in the denominator. So we'll get 780 over e to the 4x times 18 plus e to the negative 4x quantity squared. That negative in the exponent we technically would need to do something with, but we're going to go ahead and leave it in that form. That way we've gotten rid of most of our negatives in the exponents. All right, one more example. We have the quantity 7x plus e to the negative 2x squared, that whole quantity raised to the third power. So here again we have a chain rule problem. So if we have something raised to the third power, that's going to be 3 times that something squared. But since that's not just an x, we need to multiply by the derivative of the inside, so the derivative of that green highlighted part. The derivative of 7x is 7. The derivative of e to the negative 2x squared is e to the negative 2x squared times the derivative of that exponent, which is negative 4x. And not really a whole lot of simplification on this one. I'm going to go ahead and just clean up that last parentheses a little bit. So that's going to be 7, and then plus an exponential times negative 4x is the same thing as negative 4x times that exponential. Not any GCF that we can factor out, so that looks like all we need to do there. All right, I'll see you guys next time.